beech wood pellets via mild acetone organosolv fractionation. Please take the floor, Anna.
Yes, hello, good afternoon, everybody. I will present some results on bioethanol production from beech wood pellets that was achieved during the BECOOL project. This European project was presented yesterday. It was a nice session on it. And today I will present some details on the results on bioethanol production. The BECOOL project is ending this month, and it started in 2017. It's a cooperation with a Brazilian consortium in a BioValue project, and it's really focused on cooperation on lignocellulosic utilization for advanced biofuels. The biorefinery concept that is the core of the BECOOL project is the organosolv fractionation process, in which lignocellulosics are fractionated into pulp containing cellulose, mostly glucose, and a liquid fraction that is obtained by extraction using a solvent. And in this liquid fraction, you have lignin and hemicellulose is solubilized. The lignin is precipitated, and in this liquid that is remaining, there are the C5 sugars, mostly xylose, are there. And in this presentation, I will show you the results we have on the C5 and C sugar fractions fermentation. In this project, we have worked not only at lab scale, but we have worked at pilot scale. And here I show you the results from the fractionation of 70 kilograms of beech wood pellets that have been performed at Fraunhofer in Germany. And the idea was to produce C6 pulp at a high scale for fermentation, and C5 hydrolysate and lignin for for fermentation purposes or for other applications for the lignins. The enzymes used were commercial enzymes from Novozymes, and here what we can see is that we obtained a recovery of about 77% of the C5 sugars in the wood pellets, and above 90% of the sugars in the C6 fraction, in the cellulosic fraction. What we observed very soon in the project is that the C5 fraction is very toxic for the enzymes if any enzyme is going to be used in that fraction, but also very toxic to the yeast to perform fermentation. So we had a lot of efforts to detoxify this fraction using activated carbon, granular activated carbon, and to do it in a way that it can be upscaled. So what we find out is that when you have around 2% of granular activated carbon, you already can find removal of the furfural and serine. So in this graph, you can see that the removal of these furfural and serine at smaller scale, there are the black symbols. It can be reached when you have around 5% of granular activated carbon. You can have around 100% of removal, but also at the large scale, at the larger scale, what we tried, that the open symbols, we obtained very similar results. So we got very, very nice removal of these components at the pilot scale. So finally, we obtained two hydrolysates that were concentrated into syrups in order in order to have enough material for the fermentation and for the storage. So in the C5 hydrolysate, we can see that we have the xylose is the major sugar, and it was concentrated from 9 grams per liter to 324 grams per liter. And for the C6 hydrolysate, we had the major sugar was glucose, that was around 60 grams per liter, and it was concentrated to 449 grams per liter. What we also see is that the detoxified C5 hydrolysate, when it was concentrated to a syrup, we didn't have very much accumulation of acetic acid. Also, fulfural content was very low. So that is a very good result on that. The conditions for the fermentation, we did a lot of tests, different strains were tested, yeasts for ethanol production. And finally, we selected Saccharomyces cerevisiae ethanol red for the C6 fermentation and the Spataspora pachylidarum for C5. We did a lot of tests, and for the smaller scale, we can see that from the C6 sugar, we obtained very high ethanol production titers, around 90 grams per liter, with a yield, and the yields were high. So we see that this stream was quite suitable for fermentation. The C5 stream, we had to dilute it a lot. So at the end, when we dilute it at a concentration of sugar around 33 grams per liter, we obtain good fermentation. Around 94% of the sugars were consumed, and we obtained ethanol production, but it was too low, so we decided to use the detoxified one. So when we got the detoxified C5 stream, we see that when it was detoxified with a concentration of granulated activated carbon above 2% or higher, the growth of the yeast is here shown in the OD. In the graph, you can see the OD with time. We can see that the control is the green line, and when you have detoxified C5 with higher than 2, then the growth was very similar, and we could ferment the hydrolysate with 60 grams per liter with a high consumption of the substrate and high ethanol yields. After this screening work, we focused on the fermentation of the substrates prepared at a larger scale in Germany. And we used again the same strains, and we diluted the C6 hydrolysate we obtained. It contained 450 grams of glucose. It was diluted 2 times, so finally we had around 225 grams per liter. And the C5, it was detoxified too, but at the end we could only use it at a dilution of 15%. So the total sugars for the fermentation of the C5 was 56. So what we see here is at the right side, we can see that the fermentation of the C6 fraction was complete around in 1 day. All the glucose was consumed, the 200 grams per liter. We obtained about 100 grams per liter of ethanol, and the OD was also very high, so we had enough biomass, and we can see that this fermentation performs very nicely. The C5, we could see that before 2 days, the 60 grams per liter of xylose that we had was consumed completely, and we saw ethanol production up to around 20 grams per liter, so that is what we expected. What we did afterwards is to add extra C5 substrate in order to see if we could improve the ethanol titers, and we could see that it was possible to a certain extent. So the xylose was consumed, but not completely. We started supplying xylose, and we can see that we could reach 30 grams per liter of ethanol in this fermentation. So the summary of these experiments is that we could obtain a very good C6 sugar stream for fermentation using the Fabiola process, even at pilot scale. The C5 rich stream, it was detoxified using this granular activated carbon that is an inexpensive and is also possible to scale it up. We demonstrated the fermentation of the both streams at 10-liter scale. And what we are also working on, and I don't show here the results, they will be published hopefully soon. We have worked on the co-cultivation of the strains, mixing both streams. So we have been working into one-step or two-step fermentation in order to reach complete C5 utilization together with the C6. Also, we have studied this process for other substrates, not only beechwood pellets, but maize stover, hemp, wheat straw, and sorghum have been tested. And also, we have worked on bioethanol production using this strain. So this is my last slide, and I want to thank you for your attention and look forward to your comments or questions. Thank you.